Next, we continue to create another sliding joint, which involves the left clamping block relative to the rotary cylinder and the right clamping block relative to the rotary cylinder. Enter the creation page for the sliding joint. Choose the connection body as left clamping block and the basic body as rotary cylinder, specifying the vector. Observing the current tool hand, it is in a clamping state, so we select its motion vector to be outward and click Apply to complete the creation of the left clamping block sliding joint. Similarly, we select the right clamping block as the connection body, the rotary cylinder as the basic body, choose the vector, and again select outward as the positive direction, clicking Apply to complete the right clamping block's sliding joint settings. We can then close the joint creation window, thus completing the creation of the joints. During the grasping motion of the robotic arm, the movements of the left and right clamping blocks are synchronized, meaning both clamping blocks move towards the workpiece simultaneously. To ensure that their motion speeds are consistent, we need to create a gear coupler. Choose the gear under the couplers in the mechanical section. Select the main object in the gear creation window. Choose the left clamping block sliding joint for Select Master. Select the right clamping block's sliding joint for Select Follower. Set the gear engagement ratio to 1:1. And click OK to complete the creation of the coupler. At this point, we have completed the basic construction and motion joint-related constraints required for the motion of the robotic arm. Finally, we will perform position control on the robotic arm. Select Position Control under the electrical module. First, we need to control the motion speed and position of the sliding table cylinder body. Enter the Position Control page. Choose the electromechanical object. Select the sliding joint of the slide cylinder. And set its target to 62.5. indicating it should move down 62.5 mm from its current position to its lower limit position. We can set its speed to 150 mm per second and click Apply to complete the position and speed settings for the slide cylinder. Next, we will set the position and speed for the rotary cylinder body. In the panel of Position Control, select Position Control, choose the electromechanical object, and select the hinge joint of the rotary cylinder. Under the Angular Path option in Constraints, use the drop-down arrow to select Track Multiple Turns. This allows the rotary cylinder to rotate multiple turns exceeding 360 degrees. For example, we can set it to rotate one full turn at a speed of 360 degrees per second. Click Apply to complete the position control for the rotary cylinder body. Finally, we will set the position and speed for the left and right clamping blocks. Similarly, in the panel of position control, select the sliding joint of the left clamping block. Setting its target to move outward by 10 mm with a speed of 20 mm per second. Click Apply to complete the position control settings. Thus, we have completed the entire motion control process for the robotic arm. Finally, we will click the play button to preview the simulation effect, which aligns with our expectations, completing the simulation task. Today, through practical operation, we will analyze the components of the crank slider mechanism, determine the types and quantities of joints required for the mechanism's movement, create the units and joints needed for the mechanism, apply the original power to the mechanism's driving parts to drive the mechanism's movement, and complete the motion simulation. Finally, please complete the following homework exercises and practice more after class. This concludes today's lesson. See you next time.